Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 17. Alloys like nichrome, whose temperature coefficient of resistance is 0.4 multiplied by 10 to the power minus 3 per degree Celsius, at 20 degrees Celsius are used widely in the making of wire-bound standard resistors, as their resistance changes very little with change in temperature. Part 1. Find the temperature at which the resistance of a given nichrome wire would be reduced to half its value at 20 degrees Celsius. Given that the reference temperature is T naught equal to 20 degrees Celsius, we need to find a temperature T at which the resistance will be half of that its value at T naught. So the resistance at temperature T should be equal to R naught by 2, where R naught is the resistance at reference temperature T naught. By the formula, we know resistance at any temperature T is equal to R naught 1 plus alpha times T minus T naught, where R naught is the resistance at reference temperature and T is the temperature at which we have to find the resistance RT. It is given that RT should be equal to R naught by 2. Using the values, R naught by 2 has to be equal to R naught 1 plus alpha T minus T naught. This R naught gets cancelled out with this R naught, and half is equal to 1 plus alpha T minus T naught. When we take this 1 towards that side, it will be subtracted from half. So half minus 1 is equal to, we can use the value of alpha as 0.4 multiplied by 10 to the power minus 3. 0.4 multiplied by 10 to the power minus 3. T minus 20, because T naught is given to us as 20. So it will be equal to minus half is equal to 0.4 multiplied by 10 to the power minus 3 T minus T naught. So this minus half can be written as minus 0.5, and it will be equal to 0.4 times 10 to the power minus 3 T minus 20. We can write it as minus 0.5 divided by 0.4 multiplied by 10 to the power minus 3. That has to be equal to T minus 20. It will be equal to 5 by 4 multiplied by 10 to the power 3. That is equal to T minus T naught. 5 by 4 is 1.25. 1.25 multiplied by 10 to the power 3 has to be equal to T minus 20. And since minus sign was there, so we have to put it as minus. So minus 1.25 multiplied by 10 to the power 3. Minus 1250 has to be equal to T minus 20. And when we solve it out, T will be equal to minus 1250 plus 20. So the final value of T will be minus 1230 degrees Celsius. So this is the temperature at which the resistance would fall half its value as it was at 20 degrees Celsius. Let's take part 2 as well. It says state an anomaly regarding the temperature value obtained in part 1. So the temperature that we have obtained in part 1 is minus 1230 degrees Celsius. And this temperature is lesser than absolute zero. Absolute zero is 0 Kelvin or minus 273 degrees Celsius. And hence, it is not physically possible to obtain this temperature. So this is the anomaly that we have obtained. We cannot physically obtain this temperature as it is much lesser than the absolute zero value. Thank you. Keep learning, keep practicing, keep excelling.